Now, continuing on from thunderstorms, tornadoes are related. They are local cyclonic storms with violent winds that take the form of a vortex extending down from a cumulonimbus cloud. Now, I didn't name the cloud before, but a thunderstorm cloud is actually called a cumulonimbus cloud. That's that anvil shape. If you know what an anvil is, that's what's being shown here. And tornadoes, like thunderstorms, form from warm air rising and merging into these cumulonimbus clouds. And as the air is rising, crosswinds start to spin it, start to give it rotation. And that rotation is what forms a tornado. And tornadoes are associated with severe thunderstorms that produce high winds, heavy rains, and hail. And when enough rotation is achieved, you can have a tiny piece of that tornado touch down, and what actually forms a funnel shape is where we start to keep track of the tornado. So until it actually touches the ground, it's not technically a tornado. Now, tornadoes are classified on a scale of 0 to 5. And that scale is based on their wind speed. And I can show you the wind speed, but it doesn't really mean much until you associate it with the kind of damage that it can do. So an F1 tornado, for example, has speeds of 74 to 112 miles per hour, which is pretty fast. And it can blow some cars off the roads. It can move around mobile homes. So pretty severe. But if you go to an F4 tornado, we're talking about really strong wind damage where buildings are destroyed or large objects are picked up and thrown. And that's really the greatest danger to humans when it comes to tornadoes is flying debris. The faster the winds move, the more it can tear down and pick up. And that's really what causes the loss of life, is when objects are carried through the air and they hit people or hit houses and damage houses or damage cars. Now, if a tornado is sighted or there's a warning for a tornado, the most important safety precaution you can take is to find the lowest part of your house, probably your basement. Some people in areas that are always affected by tornadoes go to storm cellars and seek out those strong areas or strong places in your house and get down on the ground and protect your head or protect your body as best you can. So this is an example of the beginning of a tornado. This is called a supercell. And supercells are the precursor to tornadoes, but you can see the rotation in this storm. And it hasn't developed into a funnel shape yet, but it has the conditions that will lead to that. And as the storm gains more and more rotation, gains more and more speed, that could lead it to form that funnel shape. Tornadoes are known to occur in a very specific region of the United States. We call that Tornado Alley. It's shifted a little bit as weather patterns tend to shift, but it is the crossroads of three different air masses. You have warm, dry air, warm, moist air, and cold, dry air, all feeding into this area. And another important characteristic that kind of goes along with tornadoes is the flatness of the land. If you think about this area, it's the part of the Great Plains where the United States is the flattest. And as a result, it's very easy for tornadoes to develop on flat regions. If you think about tornado videos, if you watch them on YouTube, they always seem to occur on these really large open spaces, which kind of are part of the cornfields found in these areas. So all in all, these are local storms that really only affect small areas and have very narrow paths, but they are destructive because of their high wind speeds. And our last storm, hurricanes. Very important to us because they have come our way to Long Island and they have affected parts of New York and our tri-state area. So a hurricane is a low-pressure cyclone that forms between 5 degrees and 20 degrees latitudes over tropical oceans. And the wind speeds for a hurricane have to exceed 74 miles per hour. Depending on where you live, you may call a hurricane something different. So for us, North America, we call hurricanes hurricanes, right? But if you lived in parts of Asia, Australia, Japan. You have different names for hurricanes. Typhoons for Japan and Australia, cyclones for parts of India and Indonesia. No matter what, they're all the same. They all involve the process of evaporation from very warm ocean temperatures, and that evaporation leads to condensation, which releases energy in the form of heat, or energy in the form of joules. It's on your reference table. And that's what gives a hurricane its energy. It's that process. So the path of a hurricane is directly affected by two prevailing winds. You have the northeast trades, which are blowing close to the equator, from the northeast to the southwest. And then you have the prevailing south westerlies, or jet stream, which is blowing from the southwest to the northeast. So these are two important prevailing winds that frame the path of hurricanes. A typical hurricane is going to start somewhere over the west coast of Africa, so off in the Atlantic Ocean, off the coast of Africa. It's going to be pushed by the northeast trade winds towards the Caribbean. It's going to pick up energy. As it picks up energy, it's going to then be affected by the jet stream and carried up onto Long Island. Up onto the United States. Hopefully not Long Island. So for hurricanes in North America, let's focus on those. The season begins in late August and ends in November. And in order for a hurricane to be generated, in order for hurricane season to really begin, the temperature has to exceed 80 degrees Fahrenheit. And it's at that time you have enough energy for the evaporation of water to begin and the condensation of water to also take place, again, which fuels these storms. All hurricanes begin as tropical disturbances. And tropical disturbances are basically thunderstorms with no rotation, just a typical thunderstorm out over the ocean. Now, if that thunderstorm grows in size and it picks up some counterclockwise rotation, it can become a tropical depression. The word depression means a low pressure center. So the winds are swirling, it's rotating, it's got all the makings of what would become a hurricane. It continues to grow in size. Now it becomes a tropical storm. It gets a name. And the speed of the winds cannot exceed 73 miles an hour. A tropical storm is a classification pre-hurricane. But if it still continues to grow in size and strength by being over ocean water, that tropical storm will become a hurricane with wind speeds that are greater than 74 miles an hour. Now, the hurricane itself will continue to move and rotate and spin as it goes across whatever region it's affecting. And in doing so, it will bring a lot of precipitation, high winds. But eventually that storm will shrink. You will see a hurricane drastically reduce its size. And part of the reason why that hurricanes lose their strength is because they move over either colder water or they move to land. When they do that, they run out of the energy that they need, which is the evaporation of water. So when any time a hurricane crosses onto land, it's going to lose its energy. It's going to weaken dramatically. So here's an actual hurricane. This is Hurricane Katrina from 2006. You may remember it. I don't know. You were very young, no matter what. Had counterclockwise rotation, and the size of Hurricane Katrina, it was one of the biggest storms that has affected the United States. It was 375 miles across. If you compare, this is a very important comparison, but tornadoes are local storms. They only affect small regions, right? Only a couple of towns are affected by tornadoes, whereas a couple of states were affected by Hurricane Katrina. And Hurricane Katrina actually looked like this. This is some time-lapse footage of Hurricane Katrina moving across Florida. It's not fully formed yet, but you could see that rotation. It's still a hurricane, but it hasn't fully developed. But once it crosses over Florida, it enters the Gulf of Mexico, which is much warmer. And that's when it strengthened and got intense. And I think it got all the way up to a Category 4 storm. So there it is, rotating, right? You could see the rotation, the eye of the storm, and all of the outer parts of it, that's where you have very strong winds and heavy precipitation. So we classify all hurricanes on a scale of 1 to 5, 1 being the weakest, 5 being the strongest. And again, just like tornadoes, it has a lot to do with wind speed. But unlike tornadoes, one thing that comes along with hurricanes is what's called a storm surge. A storm surge occurs when a wall of ocean water is pushed towards a coastal area. So inland flooding is typically associated with hurricanes because if you live at the coast where these hurricanes are coming in from, it's bringing this huge wall of water, ocean water, that's higher than it's ever been before, and it brings it onto land, and causes in a lot of cases, flooding to the coastal towns. And that's why one of the most important differences in your safety precautions for a hurricane is not to go to a basement, because that's one area that might flood. Unlike tornadoes, where you just have high wind speeds and no precipitation or no extreme precipitation, you can go to a basement and be fine. But here, with hurricanes, you don't want to do that because any place that's low ground or low elevation is going to flood. So generally, there are 3 concerns with hurricanes. There's inland flooding, there's wind damage, and then there's the storm surge, which can bring intense amounts of water onto shore. All right, so we will look at those storms in much more detail, specifically hurricanes, because they happen sometimes in our area, to get a better understanding of how these storms represent the violence associated with weather on Earth. Thanks for watching.